Ladies and gentlemen, I'm very honored to be here in front of you to present the France Kérosène project that ENGIE is promoting. So first of all, I would like to express my thanks to the French government that helped us to further develop this project towards success. It's an important project for ENGIE. It's a very big decarbonization project for ENGIE, and ENGIE is committed to contribute to the development of the H2 and E molecule ecosystem. ENGIE is developing this ecosystem from the renewable power over hydrogen development towards e-fuels, but also in terms of transportation infrastructure and storage, underground storage of hydrogen molecules. So, France Kérosène, so I have only one slide to present to you, but a certain set of messages to give. France Kérosène is definitely an ambitious project. We want to produce 70,000 tons of kerosene per year, and that by a horizon 2031. We want to use for that cutting-edge technology, and this starts obviously with green hydrogen and biogenic CO2. The E-Saf that we want to produce is a drop-in fuel. The drop-in fuel is a fuel that can be used today in the same way as the normal carbon-holding molecule is used today. This E-Saf, however, is contributing massively to carbon emission reduction. So over the life cycle of the project, we speak here about roughly 80% of CO2 reduction. The heart of the project is the power-to-liquid process. So for this, we have, as I mentioned, we are starting with renewable hydrogen. We have a 275 megawatt electrolyzer system, which if you check in Europe today, this is one of the biggest systems that is today planned. We have a partnership with various players in the vicinity of the project to supply us with biogenic CO2, which is a necessary component for the project. And obviously, we have the target to produce the syngas, and for that, we will be using the Fischer-Tropsch. Fischer-Tropsch is a mature technology, and we will be using as much as we can existing infrastructure. So the project is situated in Le Havre, and Le Havre is already connected through pipeline systems to the big French airports, Roissy-Charles de Gaulle and Orly. This obviously, the reuse of existing infrastructure is a big enabler for the project. France Kérosène is definitely not a standalone initiative. It is deeply embedded into French industrial and energy ecosystem, and it is a multitude of parties that are contributing. As I have already mentioned, CO2 suppliers, but also energy suppliers, pipeline and infrastructure operators, obviously as well airports and airlines that have to use the fuel. This is part of a very ambitious target of the EU Refuel Aviation target, both in France and in Europe. And we count on such a project to reduce our import of molecules and have a domestic production of decarbonized molecules within the country. It is here, obviously, as well a call to industry. It is a very important project in terms of decarbonization targets and energy transition, but we cannot do this by ourselves. It is showing, however, that it's happening. It is a focus on innovation, and it's definitely a very exciting opportunity. In order to make this project a success, as I mentioned, we count on the support of airlines and airports, manufacturers, policymakers to create a stable environment for such an investment, and obviously investors, of which ENGIE is one of them. Maybe just a last word, France Kérosène, you have seen how it's written. There is no typo in the text. Obviously, it's in France. It refers to kerosene as fuel for aviation. It's based on electrolyzer, so water being transformed to hydrogen, and it targets zero emission net in France through such a project. So I'm very happy and excited, and if there would be questions, then please be so free.
Any questions? Yeah. Thank you very much. Maybe I missed it and you said it, but for the production of the electricity, will you have your own production system, or how will you procure the renewable electricity?
Yeah. So I think thank you for the question, a very good question. I think this is one of the advantages that we have in France. If you know the European regulation around renewable and decarbonized hydrogen, if you are in an energy system that is already decarbonized by 80% at least, which is the case for France, you can use certain exemptions to the rules. That's to say, you can use existing power assets that are possibly already subsidized in the system. You can also take power from the grid. So for instance, nuclear power can be used for such a project. However, the target here is to use massively renewables for such a project. In terms of scaling, we speak about 2.5 terawatt-hour of power on a yearly basis, which is massive. And we want, obviously, to use part of ENGIE's own production park to element such a project, but we'll also source it from the market.
Thank you very much. I wanted to understand, you mentioned Fischer-Tropsch. Will you be using your own technology in Fischer-Tropsch, either catalyst or process? If not, are you solely going to be a project developer, bringing together all the different elements?
Well,
Thanks.
ENGIE does not have solutions or a technology in Fischer-Tropsch. We are not a chemistry company, we are an energy company. So we have today already selected the partner that will supply the technology for the Fischer-Tropsch. We cannot divulge the name yet, because this will be signed between now and September, so it's well advanced. So the technology has been selected, and it's not in-house technology.
Do we have one more question? Yeah.
Practical. Thank you again for your presentation. Maybe one quick question, maybe you mentioned it, but what about CO2? What are you doing about that? Where are you getting it from, and how you see the future beyond 2040?
Yeah, so the 2040 question is very important because that puts the end to non-biogenic CO2. This is why today we target 100% biogenic CO2 in order not to have this breaking point. And obviously, we're targeting very long-term supply contracts with CO2. So there is a multitude of how to procure the CO2. In certain cases, we will invest into the CO2 capture on a site. So basically, our supplier will sell us the feedstock, and we will capture and transport and use. With others, it's just the feedstock that we're buying. So we have today contracted from 5 various sources, over 100% of our needs. We're still looking for it, so if there is interested parties, we're more than happy to be in contact with you. But it's definitely 100% biogenic.
Thank you. We have the time for one quick question, if you have any. I think we're going to wrap up. Perfect. So thank you.
Thank you.
Thank you very much. The next project is Take Care from Hynamics EDF.
Hello, everyone. Thank you very much for the Paris Air Lab and the organization for hosting us today and allowing us to introduce ourselves and present our project. So my name is Arthur Parenti. I will be representing Hynamics, which is the hydrogen subsidiary of the EDF group, specialized into electrolysis, so hydrogen production using only water and electricity through a process that does not emit CO2. We develop projects in several fields of the economy. We decarbonize road transport through assets which are already in operation, where hydrogen is directly used as a fuel. We decarbonize industry, while displacing fossil hydrogen by clean hydrogen. And we also combine the hydrogen we've produced with CO2 to produce synthetic fuels which have the advantage to be liquid fuels usable in current engines in the maritime and the aviation sectors. And today I'm going to talk about one of those projects, which is the Take Care project, the flagship project of the FDF group in terms of synthetic fuels production, more specifically e-kerosene to decarbonize the aviation sector. So what are we talking about? We are talking about a greenfield factory that will be able to produce up to 38,000 tons of e-kerosene per year by combining the hydrogen we produce on site and biogenic CO2 that will be captured by local industrials and brought by pipe into the factory. The kerosene we will produce will be 5 times less emittive than conventional kerosene, which will allow us to avoid nearly 130,000 tons of CO2 per year. So the factory is 100% electric. There will be no fossil energy that will feed the process. And most of the electricity, so we are speaking about 1.7 terawatt hour per year. Most of the electricity will be used to feed the electrolyzer that will produce the hydrogen for the plant. So it's a massive project. We are talking about 1 billion euros investment as we are building a whole factory from scratch. And we target the commissioning date by 2030, 2031, depending on external factors like the infrastructure needed to carry the CO2 all the way to the plant. So if we look a bit at the detail of the process, so this is pretty innovative. If you take the bricks one by one, everything is kind of mature. The real innovation inside the project is to integrate all those technology together into an industrial process. So within this process, there will be 3 main inputs. So the first one is the CO2. So we are talking about biogenic CO2 that will be brought to the site through a pipeline, namely the Go CO2 pipeline. I will show you a map just afterwards. We have electricity. So a lot of electricity, as I said, mostly to feed the electrolyzer, and reused water that will come from wastewater treatment plants, which will be just nearby the factory. So we have the hydrogen production that will be combined within the reverse water gas shift brick with the CO2 to produce a syngas, so a combination of carbon monoxide and hydrogen that will feed the Fischer-Tropsch to produce liquid fuel that will then be upgraded to separate the different products. So we have 2 products, the main one, kerosene, so 38,000 tons, and a byproduct, which is the naphtha, so e-naphtha, around 12,000 tons, which can be used in the petrochemical industry. So for those technology, us, Dynamics, our specialty is the hydrogen production. We develop the plants, but we are working with partners, so namely Axence and the FPEN. So, and by the way, if you want to know everything about SAF, I encourage you to go see the FPEN at the entrance of the Paris Air Lab, where they will explain to you all the different pathways existing to decarbonize aviation. And then everything will be transported to other location where you can blend the pure e-kerosene into conventional kerosene and added to have the jet fuel. So we are lucky enough to be in a strategic location. So within the industrial area of the Saint-Nazaire port, Western France, where we can benefit from a lot of synergies. We have the grid connection, so as I say, we need a lot of electricity. We have the access to water, so we need water for the hydrogen production, and we have the wastewater treatment plant just nearby, and we have some docks, which are currently used by the Total refinery nearby for petrol product logistic that we'll be able to use as well, namely to carry all the product all the way to Le Havre, as you can see, where the fuel will be blended and injected in a trapel to feed the airport, the Parisian airports. And here, as you can see, is a 3D design of what the factory would look like at its commissioning. So thank you very much for your attention. Again, thank you also to the French state who is supporting the project through the CARB Aero program, which will allow us to go forward with the engineering studies, which are very big when you're talking about creating an all new factory. And yeah, I'll be very happy to answer all the questions you may have.
Thank you. Do we have any questions? No question. Oh, yeah, one question.
Hi. I wanted to ask how you are going to source CO2 for this scale of production is quite significant, and direct air carbon capture isn't mature yet. Of course, it's very costly. Biogenic CO2 obviously is not available at this scale. So I was interested to understand how you scale.
Yeah, very good question. So I didn't go into the details. But yeah, we are talking about a need of 160,000 tons of CO2 per year for the production. So you need indeed big emitters, big CO2 sources. So the advantage of the location we are in is that we are on the pathway of what you can see here on the map, which is the Go CO2 pipelines, which is going to connect the big CO2 emitters of the region, more specifically cement plants, all the way to the port, where you have a share of the CO2, specifically the biogenic share that could be recycled within our plant in fuels, and the industrial share from fossil combustion that will be sent overseas to be stored. So we have access to the CO2 through this infrastructure, and basically 160,000 is the biogenic share of the CO2 coming from the combustion of biomass from one cement plant.
If you have one more question, we have time for a quick one. No? Okay, so we're keeping the timing. Perfect. Thank you very much. And the next project is BioTJet from Elis Energy.
Hello, everyone. I'm Pascal Pénicaud. I'm a co-founder and president of Elis Energy. And before I start talking about our company and our project, I would like to give a special thank to the French state for the support through this CARB Aero 2 call for tender. And I would like also to thank our partners in the project, Axence, who is here today, IFPEN, and Bionext, who are with us from the start. I would also like to thank our team. We have over 80 employees now, and they are committed every day to make these projects a reality. So, first, I come after NG and EDF, so I have to explain to you who we are at Elis Energy. We are a French SME, and we are specialized on the production of low carbon molecules. So we act as a project developer. We overview construction and operation of e-fuels facilities. And we are specialized in two types of molecules. We produce e-methanol, and we also look at sustainable aviation fuels. As I said, the company is a French company. We are based in Paris, Lyon, Marseille, and Pau. And we also operate at larger scale on other European markets. We are specialized in three different technological bricks. Obviously, the production of green hydrogen through electrolysis, carbon capture, and we'll come back to this because our BioTJet project has a specific technology on this, and obviously the conversion of H2 and CO2 into low carbon molecules. So our target is not only the aviation industry, we also target maritime industry through methanol and the industry also to decarbonize hard-to-abate sectors. So let me dive into our BioTJet project. The BioTJet project is a project based in Lac, which is southwest of France, which used to be a key place to produce fossil gas in the past in France. It used to produce up to 30% of the French national consumption. And it's a place that is now redirecting into new fuels, biofuels and e-fuels, and becoming a new harbor for production of low-carbon molecules. This BioTJet project is specific because it's not a pure E-Saf project. We are using a hybrid pathway. We are using biomass gasification as a source of carbon and hydrogen, and we are co-processing this with green hydrogen from water electrolysis. So the project produces over little over 100,000 tons a year of low-carbon molecules, mostly SAF and naphtha. Because we are using this hybrid pathway that is using biomass gasification and green hydrogen, our production is 50% biosaf, what we call 2G second generation biosaf, and 50% E-Saf to cover the European Union mandate. The project, as I said, is based on a French and European technology, which is called BioTFuel, which is basically has been developed since 2010 by a consortium of French and European companies, which is basically the adaptation of a coal-to-liquid technology to new molecules in order to produce sustainable aviation fuel. The project was started in Lac in 2023. We have performed our pre-FEED phase. We are in the process of submitting permitting application to local authorities, and this support from the French state will help us to fund the next phase of the project, which will be the FEED phase to start end of this year. This project is key for Élise Énergie. It is our only SAF project, and we have been working on this BioTJet project since the start of the company. Maybe you have some question. That's all I had to say regarding our project. Thank you very much.
We have time for, yep, for a few questions. You don't even have time to finish my sentence.
Thank you. Thank you very much. So the biomass sources, what it is more specifically?
Yes, so the biomass sources, we are looking at 300 kilotons per year of dry biomass. And we have, obviously, what is eligible as second-generation biomass in the RED III regulation. And we are targeting 3 types of biomass. First is forestry residues for 1/3 of this amount. Second is agricultural biomass. And the third part is roughly wood waste from the waste industry.
And so for the logistic of these residues, everything is in place. You have a clear idea on how to collect this kind of biomass around the plant?
So you are talking about the many challenges we are facing, and one of them obviously is the collection of the biomass. I would say it's quite different regarding each feedstock. Forestry residues, forestry industry is an existing industry. We are speaking about 100,000 tons a year, which is reasonable amounts, but it's not anything new for the industry. So we believe from now to commissioning, which is 2030, that the industry is growing and that we have enough time to actually help existing players to bring additional feedstock. Waste is different. It's already collected. And interestingly enough, today there is no facility in southwest France to use this feedstock. So it's sent through trucks in other countries, Northern Europe, Southern Europe. So the idea here is to work with local players to see how we can gradually have, let's say, local use of this waste and stop sending it abroad and trying to use it locally. The one feedstock that will take more time is agricultural feedstock, obviously, because you're talking about feedstocks that are whether existing but not collected, so you have to work. For example, looking at the wine sector, they have a lot of sarment de vigne. I don't have the English word, but now they are burning these at the spots because they can't use them as a waste, and we would be able to use it in our process. But that would require to set up a new supply chain. So I would say the main challenge for us remains on the agricultural biomass.
Do you have any question? No? Okay. Thank you. Thank you.
Thank you very much.
And now it's time for the last project, Désir from Verso Energy. You can applaud him, please.
Hello everyone, so I'm Romain Verdier, Deputy CEO of Verso Energy. Thank you very much for having us here and for giving me the opportunity to introduce you Verso Energy and the Désir project. So what is Verso Energy? Verso Energy is a French energy company, not only a power-to-gas, power-to-X developer, but a full energy company that is producing electricity, developing flexibility solutions, and developing projects of hydrogen and e-fuel. Regarding the electricity generation, we have currently 40 megawatts of solar farms in operation in France, and it will be 100 megawatts by the end of this year, and we are targeting 2 gigawatts by the end of this decade. We will be launching the construction of our very first battery in the next week, and then we develop also some hydrogen and E-Saf projects in France and internally. Hydrogen to decarbonize the industry, to decarbonize the refineries, and then some E-Saf projects. And I will give you some details about one of them, which is located near Rouen, near Rouen. It's a project that is composed of 4 different parts. First part is the CO2 captured. The second one, the electrolyzer. Then the third part is the methanolation, and then the last part, the methanol to jet bricks. The CO2 is the biogenic CO2, of course, is already secured thanks to a partnership with a biomass boiler that is located in Alizé. And the CO2 will be sent to our Désir project through a pipe, a CO2 pipe. It's a 10 kilometers ahead. And so this project, as I mentioned, this is in fact 4 different projects. It's based on the methanol to jet pathway, which will procure flexibility in terms of operations, and that will guarantee a smooth integration in the electricity grid system. It will enable to produce more than 80 kilotons per year of E-Saf. and it will be commissioned by the end of this decade. Currently, we have ended the local consultation. The FEED is underway, specifically thanks to the support of the French government. So obviously, the grid connection also is secured as well as the land. So I think everything is on track. Verso Energy is not a single project company. We have a lot of other projects in France and internationally. So we have think about a standard project regarding E-Saf. So we have developed. We are currently developing the very same project in some places in France. This is the same project as in Rouen. So it is the project Épine in Épinal, Lichen near Limoges, and Restart in Tartas dans les Landes. We have also under development 2 projects in Finland, and the last one is in the US, in the state of Georgia, which is with a partnership with RYAM, which is the CO2 emitter that is operating currently a facility in Tartas. So that's why we have crossed the ocean to develop the very same project in the US. And I think I've said all I should say. So we are very proud to be part of the E-Saf journey, and I'm sure right now that there will be enough product on the market by 2030, and thanks to all of our projects and the free ones before. Thank you.
Thank you. Do we have any questions? Yep.
Sorry for another question. Thank you very much. Just a question. Yeah, just a question about this methanol process. Is it already approved by ASTM? And if it is not, what is the reason for approval?
I think that this is in the very last stage of certification, and I understand that it's a question of weeks or some months, but it's the very last stage of the certification.
Yeah, another question here.
Thank you. Why methanol to jet?
Sorry?
Why methanol to jet?
Why methanol to jet? Because it gives us a lot of optionality. It's a very flexible technology. I think it is important to have a flexible technology when you are in France, because in France you have a lot of electricity. But you have some period of power scarcity, especially in the peak hours in the winter. So it is necessary to be able to operate in a flexible way the assets. And the second answer is the ability to use imported methanol and temporarily to shut down the electrolyzer and the methanolation bricks in order to import some methanol from outside. So it improves the robustness of the project.
Thank you. Do we have... Yeah.
Yeah, so methanol can also be used to decarbonize the shipping industry directly, taking away the risk of going to methanol to jet, which isn't approved yet and which could have issues in the early production. Is this something you're looking at as well, or you want to go to methanol to jet directly?
We want to go to methanol to jet, that's for sure, but this is a third option that is provided as this project. For sure, if we have some surplus of methanol, we will use it to decarbonize the maritime sector.
Do we have one last quick question? Yes?
You said that you choose this process because of the instability of the electricity production availability, but I thought that electrolyzer did not like discontinued operation. Did you solve this issue with electrolyzer?
In fact, the flexibility is useful in order to manage the high prices. It's not a question of frequency or things like that. So it's a question to be able to lower the load of the electrolyzer in very short period of time in the winter. And yes, those facilities are supposed to run most of the year, very high load factor, and they are made for.
Thank you very much. So that was the last project.